I will tell you a fascinating story about basic research with no applications. If ultraviolet radiation hits a biological molecule, it can get destroyed. But the molecule on which our life is based, DNA, is surprisingly stable against ultraviolet radiation. So how did nature manage to make this molecule so resistant? If ultraviolet radiation hits a molecule, it gets excited, and an excited molecule can react. DNA actually gets rid faster of the excited energy than a reaction could happen. So to investigate this deactivation mechanism in detail, we have to investigate its ultra-fast dynamics. I want to explain you our technique by an example. This sprinter on the left, if you want to know how he moves, you will not be able to capture all the details by your eye because your eye is not fast enough. But you could use a stroboscopic technique. So if the sprinter hears the starting signal, he starts running, and after a defined waiting time, we illuminate him with a flash of light, freeze by this the motion, and can take a picture. By taking several snapshots at different waiting times, we can record the whole motion and can investigate it in detail. We use a laser-based technique where one laser shot excites a sample and a second laser shot investigates the sample. So the second laser shot actually shines through the sample, and by the transmission of the different colors, we get information about the energy of the excited state. So I investigated two different samples. So in the middle, you see the basic building block of DNA, and on the right, you see a strand consisting of different building blocks. We investigated how the interaction in this strand affects the dynamics, and we figured out that the interaction slows down the deactivation process by 2 orders of magnitude and leads to a different excited state. So coming back to the big questions of life, did we now figure out how nature managed to get rid of this excitation energy in detail? Unfortunately, our sample molecules are quite far away from biologically relevant DNA molecules, but we developed a set of tools to investigate more relevant systems. Thank you.